Hi guys and welcome to the Data Rush. In this episode of the Data Rush, I interview Harveen Singh, who is a data scientist at Thoughtworks and is also a contributor to the open source automatic speech recognition system Vakyansh. So hi Harveen and welcome to our episode.
Hi, Amrinder. Glad to be here.
So like for anybody who does not know what you do, so can you introduce yourself and the work that you do to our audience?
Sure. So, my name is Harveen. I have close to 7 years of industry experience with more than 5 years in AI and ML. I work as a data scientist in Thoughtworks. Prior to Thoughtworks, I worked with the CTO team of Wipro and the special technology group in Infosys. So basically, my work in ThoughtWorks is more around an open source developer. So basically, we are creating automatic speech recognition for Indic languages, and we are targeting almost all the Indic languages in the first go, with a couple of more languages in the second go once we have developed systems for the 22 official languages that are present in the constitution as of now.
Okay, that sounds great. Yeah, so
Yeah.
when you started initially, so yeah, you started from being a software developer and
Yes.
now you're into a data science, right? You are in like a data scientist. So
Mhm.
how was that journey and like how did software development enable you and like help you in like now being able to make better AI solutions? Because as we see, like even AI solutions are sort of a software program only, right? It's package around that while the core technology or like the core functioning mechanism could be AI, but like the way you deliver it
Mhm.
follows like the basic software development pipeline or life cycle. Yeah.
Yes. So absolutely, I think the core principles of the software development are very much important in developing any solution, not just AI solution. I think any solution. So yes, I started as a full stack developer in Infosys. So I was working on the main stack, which is Mongo, Express, Node, and Angular. And then I switched to the MERN stack with React as well. And that was pretty good time. I mean, I was working as a full stack JavaScript developer, and even today, I mean, that role has a lot of demand, if you ask me. But in 2017, I had a choice to go for an opportunity outside India or to learn about AI within India with the top people at Infosys. So I chose not to go outside, but to stay here and actually learn about AI and ML in 2017. And we worked on a special project which was on self-driving cars. Okay, so the intention of the project was to create an autonomous vehicle within the Infosys campus. Okay, so that we can try out different techniques like deep learning and robotics and understand that how this technology can mature going forward into the space. As you know, like Tesla has a fully autonomous, not fully autonomous, but semi-autonomous solution just using the cameras, right? So we were also trying to create something using the cameras, lidar, and radar as a sensor. So my journey started from that point in AI and ML. So I was in the team of detecting. I mean, I was in a team of which used to create object detection solutions. So we were using deep learning for object detection. So real-time deep learning on the autonomous vehicle to detect objects like a traffic light or a person or a car or maybe anything, any obstruction on the road, right? So for whatever the output we got from the detections, we used to then actually apply some rule-based approaches on top of those detection to decide whether the car should slow down, should go left, should go right, or should accelerate in the normal manner.
Okay. So in this how was your data collection strategy in regards to like when we're
Mhm.
talking about object de- object detection, right? Because in the like vision systems wherein we have multiple inputs, even a single camera won't do, right? So either you'll be using multiple cameras or then multiple sensors and like
Mhm.
considering all those inputs and then maybe deciding upon all that. Yeah. So if you could little bit
Yes.
elaborate on that. Yeah.
Yes, so see, it went like this. Like we had a single camera, first of all, to start with, and we had a stretch of road. I mean, you can say we had a stretch of road like 2 to 3 kilometers So we used to run our autonomous vehicle manually through those 2-3 kilometers to collect data, and we used to do it at different times of the day, in different weathers, so that and in different crowd conditions as well, so that we can collect data in as many different forms as possible. So that was one way of collecting the data. And the second way was like, obviously, like you said, I mean, you tilt the camera 30 degrees to the left and you tilt the camera 30 degrees to the right, and you have a whole new different perception, right? So you also have a different perception from the 0 degree and -30 and +30. So basically, you are getting three images from a single camera from a single view, right? And those three images are treated as three different images in neural network training and all, right? So that was the second approach. The third was like we used to collect simulated data. So we used Carla simulator to collect data, synthetic data. Okay. And the fourth was obviously the data augmentation techniques. I mean, how can you introduce varied atmospheres, varied environments, varied weather, varied lighting conditions, anything. I mean, so we use a lot of augmentation techniques as well to collect the data from the autonomous vehicle when we run. The challenge with the more data collection was the more data labeling, right? So the more data that you collect, the more you have to label as well, right? So if you want to detect a person, then if you have clicked a photo, then you have to manually label using some tool in which you have to tell like where exactly the person is. So we used an automated a pipeline to do some of the labeling. So automated pipeline in terms of we already had object detection models at that point of time that were able to detect the person, car, or something. So we used those models to detect the person in the image. So that was our plan for the automated. So data was ours, but we used pre-trained models to label that data to generate our specific data on which we wanted to run our autonomous vehicle on.
So definitely, whenever we are training, so for that, in order to build models or systems that are more robust, so you definitely need to introduce like a lot of variation in the data. Otherwise, it might be a lot of bias in the data and then the model as well. So this was the case of the vision problems, right? Now you are also working in NLP, in automatic speech recognition, right? So if we talk about NLP, right, or speech, right? So in that case, the variation would be maybe if there is noise, or maybe if the person is speaking from a farther distance, or maybe there's some multiple people who are talking, right, and you want to identify the main person who is speaking. So in regards to NLP, and in regards to the project that you're doing at Vakyansh. So how do you introduce when you're processing the data, how do you introduce augmentation in that case to make that data more robust, or add variation in the data?
Right. Yes. So augmentation in terms of computer vision is really, I mean, easy to do as compared to NLP or speech, because you can have synthetic filters, you can have synthetic lighting conditions, and you can check the output as well visually, right? How does it looks like and all. But in case of an NLP and speech problem, the process is a little bit different, right? So in case of NLP also, the process is different than that of speech, I would say, because in NLP, you basically work only with the text data, while with the speech, you can do a lot of different variations. Like what we saw was the first thing is environment, in which environment the person is. Okay, like if I'm sitting in a closed room versus you're sitting in a cafeteria, right? So how does the sound differ, right? So whether there is an echo, whether there is a reverb in the sound, right? So you can introduce those filters synthetically in the data set. And the second problem was the device that is used to record, right? So my device of recording is different than your device. I might be using a condenser microphone, while you may be using a laptop microphone, right? So how do you collect data in such a varied way that it covers all the devices as well, right? So in that case, I think we used a lot of different techniques to lower down the quality of audio. Okay, so basically the output of audio, I mean the output of a condenser microphone and the output of normal microphone is different. Okay, so if we can tamper the output in such a way that the output from a condenser microphone looks like it is coming from a normal microphone, uh, then that is what we were able to achieve doing speech thing. And the third thing is artificial noise, right? As I said, I mean, you might be sitting in a metro, I might be sitting in a closed room. So for that, there is a noise data set that you can have. I mean, you can introduce artificially into your speech recordings. So basically, if you have one signal and if you have the second signal, you superimpose both of the signals together to get a final signal which contains the noise plus your speech output. So we actually did a lot of these augmentation. And the fourth one is like loudness normalization, right? So my way of speaking might be different than yours. My way of speaking might be louder than yours, right? So the people, I mean, we also used to do the loudness normalization, and then we also have what we call as pitch normalization, right? So my the pitch of my voice is different than the pitch of your voice, uh, and the pitch of a male voice is different than a pitch of a female voice, right? So we need to so if we cannot afford to have a huge amount of speakers in the data set, so we need to artificially create speakers, and by changing the pitch, by changing the loudness, by increasing the noise, we are synthetically creating new speakers in the speech data set that we did. uh, Coming to NLP, coming to the text data, like how can you augment the text data? Of course, there are many techniques in NLP. So one of the famous techniques is back translation. So you basically, whatever language that you are working on, you translate it to some other language and then translate from the other language back to the original language. So you will have a modified version of the original sentence, right?
Yeah.
So this is one of the very varied approach that is being used in NLP. Of course, I mean, all three fields are different. The vision is different. NLP, I mean, the text is different, and in the speech side, it's a lot different.
Yeah, so definitely, like when we are talking about speech recognition, or like NLP, or like any like for example, if we talk about image, right? In that case, even before starting building the models and everything, the domain knowledge in the sense, like how does a picture look like, what contributes to a picture, like what is saturation, what are the different parameters, like
Mm,
uh, in like speech also you
mm,
might have also had to work upon, like how would a sound engineer interpret the same thing, right? Because what
mm.
is pitch, what are all the different various factors. So
Yes.
maybe the domain knowledge in the sense of understanding, like how
Mm,
audio waveform looks like what it represents and all that. So
yes.
definitely.
Yes, absolutely. I mean, there is something known as a MEL spectrogram. So a lot of algorithms have come around the MEL spectrogram. So basically, people used to convert speech signals into spectrogram, basically, which is an image, basically, and then apply on those spectrograms CNN algorithms or any rule-based algorithms to get a model on something on that. Uh, but the modern speech recognition techniques work on the raw audio waveform. They say that you just give us the raw audio and we will figure out how to encode features using different CNNs and the combination of transformers and RNNs. So
Yeah.
earlier it used to happen with the MEL frequencies, the MEL spectrograms, but now I think most of the state-of-the-art algorithms work on the raw waveforms rather than a spectrogram or another waveform.
Okay, so like I was also looking into this specific thing. I guess there's this approach of, I guess, CTC, wherein temporal like
Mhm.
classification you do, in that maybe you have waveforms where from where like you
Mm,
extract the filter and then create maybe spectrograms, and then uh,
mm,
encode that maybe like using some sort of RNN, or so that eventually you can figure out like what all
mm,
text, what all text is being spoken. And then maybe they were also having this thing, like for example, I'm saying the red box, and in that the waveform, the I
mm.
might speak the letter T multiple times, and then yeah.
Yeah. So basically, the problem with speech is that your input and output lengths can be varied, and there is no fixed pattern to it, right? So you
Yeah.
can have a 10-second audio, while
Yeah.
the only text that it can contain is the box, as you said, right? Whereas in the other 10-second audio you can have a complete sentence, like the quick brown fox jumps over the fox, right?
Yeah.
So you can have the complete sentence. So how do you fix this problem? So I'll tell you very naive way, because if you go into details, it would take in a lot of effort and all. So the raw audio waveform is fed to CNNs, which encode features from the raw audio waveforms. Those features are then sent to the transformers, which actually learn the sequence information, like what is the sequence of characters coming in. And
Yeah.
on the top of transformers, there is a fully connected layer that actually classifies what happens in a particular frame. So when we are talking about a frame, we are saying a 25 millisecond frame, okay? Because if you understand CNN with images, there is
Yeah.
a particular window size in CNN, right? So the
Yeah.
same window size in speech is the number of milliseconds, right? So you have a 25 millisecond window which you can slide across the audio input, and you can extract features out of that audio input. And once those features are extracted, you can actually pass those features to transformers, which can learn the sequence between different characters. And after the transformer has learned the sequence, there is a fully connected layer that predicts what is the output that is expected in this particular frame. Now you talked about CTC. So it is possible that the same character is predicted by multiple frames, right? If the
Yeah.
sentence is the box, right? So
Yeah.
it might be possible that T is predicted 48 times, and
Yeah.
then there is an underscore between T and H is predicted maybe 10 times, and then there is an underscore between H and E, which underscore is a separator between different characters, okay?
Yeah.
And then there is an E which might only be 5 or 6 times. So what
Yeah.
essentially CTC does is that it collapses all the multiple representations of a single output. And I mean, all the 40 T's are collapsed down to a single T, all the 10 H are collapsed down to a single H, and the word is combined to form a single, I mean, all the characters are combined to form a single word. I mean, this happens sequentially with different words, and hence we get the speech recognition output.
Okay, so like in this, when we are talking about the specific window that you're talking about, is it similar to the LSTM, wherein we have a specific window till which the we have the context of the words, and once
Yes,
that, like for
yes.
example, we, yeah, you're getting me right, yeah,
Yes. So, not in the LSTM context, but I would say in the CNN context, right? So, if you have to see the entire image, suppose you have an image size of 600 cross 600, while your kernel size is only 6 cross 6, which
yeah,
means that at a given point of time, you can just see uh,
specific features for,
36 pixels at a time, and you can slide the window accordingly across the image to the right and then to the down, to the right and to the down, until you have seen the entire image, right? Because whenever I talk about encoding features or getting the features, then CNN is something that comes to my mind. LSTM is also good, but it is for the sequence information, not for extracting the features, I would say, but for
yeah,
the sequence information, like how this word would be followed by this word. Okay, maybe this character is followed by this character. So all that type of information is encoded by a LSTM or an RNN or a transformer, a more advanced form of an RNN LSTM transformer.
yeah. Okay, so like this is when we are talking about how we process the data and all. So like when we are talking about voice-based systems, right? Generally, in order to build a better solution, the first and important thing is the data, right? Uh,
Absolutely.
and like even before starting to build a solution, you will see whether I have data or not.
Mm,
So it is this like something in artificial intelligence where we are talking like all the models that are being created
mm,
have a bias based on the data, right? Because
mm,
I can give the example, like for example, if you are training a model to recognize images, right?
mm,
And the people who wear turban, right?
mm,
in that data set, the people who wear turban is not there. So maybe
mm,
I might get recognized and somebody who is bearded, right? Maybe a
mm,
Muslim, right?
mm,
Because the data is like there's like a lack of data in
mm,
that sense. So like when we are
mm,
talking about uh, Indian languages, right?
mm,
Collecting data in Indian languages, even
mm,
before building solutions. So like, how did you guys in Vakyansh like approach
mm,
the process of data collection? Because
mm,
obviously there's something wherein you can like improve the algorithms, right? But
mm,
being data centric in that sense,
mm,
when you're starting the models
mm.
building. So if you can like elaborate on that data collection part.
Sure, sure. I'm glad that you brought this topic up because, as you said, I mean, there is a bias or we are not able to cover all the cases. So I can give you one example. So one of the very popular researchers published an algorithm to cartoonify yourself. Basically, you can convert your image to a cartoon. Okay.
Yeah.
So I tried that algorithm and I tried giving by my image. But as you said, I mean, there were no images with the turban in the training set. So
Yeah.
in my case, it totally removed of the turban in the output image, and it was not able to find out what to do with this image, right?
Yeah.
So yes, I mean, covering all the edge cases and all the cases is really hard thing. Okay, and what we can do is we can do our best to cover all the cases, but we need to know the limitations of our algorithm as well. Okay, what are our data limited to? What is our correction strategy limited to? Right. So in Vakyansh, the beauty of Vakyansh is that when we started this project, we had no data. We had zero data. Okay, and still now, if you see the Indian landscape, you will see that there is uh, I mean, a lack of data. I mean, nobody is publishing speech data sets at the moment. I mean, for English, there are a lot of speech data sets like
Yeah.
Libri Speech, Timid, Switchboard. But for Hindi and other Indic languages, you don't find data enough. I mean, things have started to improve. I mean, I can see a lot of improvements in the speech competitions within India, and the government is also pushing for the collecting the data in your local languages. But right now, if you ask me, there is no uh, huge corpus available. I mean, we have a corpuses around 100 hours, 200 hours, but not somewhere around like 1,000 hours, 5,000 hours, so 10,000 hours. And so why you need a huge corpus? Because they say that if you want to build a good speech recognition system, that is a production grade system, you need
Yeah.
at least 10,000 hours of label data.
Yeah.
Okay, so if you have to build a speech recognition problem, if you have to build a speech recognition product in Hindi, so you need to have 10,000 hours of data in Hindi, and that data should be labeled. Okay, and the main problem with this data approach is you cannot have one speaker speaking the entire 10,000 hours. Okay,
Yeah.
so you need to have a variety of speakers. So you can say that a maximum of 30 minutes per speaker. Okay, so if you have to collect 10,000 hours, you need at least 20,000 speakers. Okay.
Yeah.
And these 20,000 speakers cannot be completely male. Okay. So 50% have to be male, 50% have to be female, right? And when we talk about male, we cannot say that, okay, all data is collected from an age range of 25 to 29 or 25 to 35. We have to make sure that the data is collected in multiple age ranges, like 19 to 23, then 24 to 30, then 30 to 37, and so on, right? So if you want your model to work better in all the cases, right? So this is the ideal thing that should happen.
Yeah.
And a lot of these things are actually quite difficult to do. Okay, if you ask me, I mean, uh, getting even 20,000 speakers for Hindi is a little bit tough, right?
Yeah.
And we also launched a crowdsourcing portal where we are asking people to come and donate their voice. And a lot of people did that. But again, I mean, to maintain a consistency of data coming in, it is very difficult to do that, right? So we needed something like an automated fashion, right? So we wanted something that if we have the audio, then we have the corresponding text according to the audio, right? So we built our own data pipelines that did that. Okay, so basically we used to scrape open source audio on the internet, Okay, so suppose an audio is of 30 minutes long. The audio is 30 minutes long, suppose. Then we used to run something known as voice activity detection. Okay, so this algorithm detects where you can break the audio without losing the words in between. Okay, so why do we want to break the audio first? Because the limitation of our machine learning algorithm is that at max it can take a sequence of 15-second length. Okay,
Yeah.
so it cannot take a sequence more than 15 seconds. So you need to break down larger audios into smaller chunks and then transcribe those chunks in order to create label data. Okay, so what we did was we had a long audio. We ran an algorithm called voice activity detection, which used to break down a long audio into smaller chunks and which used to tell me places that whenever I incur a silence, then you can split the audio so that your words are not getting lost between two segments, right? And once we have those segments, suppose 30 minutes gave me 3000 segments, okay? And once we have those segments, we used to pass those segments to a SNR algorithm. So SNR is basically signal to noise. Okay, so there is a threshold for SNR, which is like if you have a value between 20 to 50, then your audio is good. Okay, but anything less than 20 or anything greater than 50, it is not good. So then we used to filter out which are my best segments using the SNR algorithm. So once I've got the best segments, then we used to have automatic speech recognition engines that are currently provided by Google or Azure or AWS to get the transcript. Okay. So basically, you have a long video, you break down into smaller chunks, you pass those smaller chunks to a SNR algorithm, which tells you which is a good signal and which is noise. And then whatever is a good signal, you pass it to a commercial speech recognition engine that is present at the moment, and you get the transcript from it. So this was one of our ways of automating the data pipeline and collecting data for different Indic languages.
Yeah. So in this, I would like to ask this specific question, like as you mentioned, like for example, if we are training and in the initial data, we need to consider different like age groups, because obviously the vocabulary would be different for different ages, and apart from that, if we talk about male or female, right, and then the pitch would be different, right? So, like when we are talking about in this scenario wherein we are collecting data from all the different sources, so how do I say it?
Yes. So what are the problems basically, right? So collecting data from different sources, right? So I can elaborate on some of the problems, like when once you're scraping the internet, right? So you get a lot of noise, you get a lot of songs inside, and we don't need songs. Okay, basically we are saying that we need audio which has a little to minimum background noise. Okay, so we don't need songs. If there is some background music in the start or the end of the video, then that is taken care by the SNR algorithm, because it filters out that as a noise, right? But if the entire video is noise, if the entire video is song, then basically the voice activity detection would not be able to cut down a larger audio into smaller chunks, because the voice activity detection looks for silence. And if there is a particular background music that is running in the loop in the background, then you won't be able to cut a larger video into smaller video. Okay, so that is a limitation. So what we are saying is we do not need songs. Okay, that was the first thing problem that we faced, right? And the second problem that we faced was people have done wrong tagging of videos. Okay, so if somebody is saying this is a Hindi video, but when we listen to that video, it was basically a Tamil video. Okay, so this is a very common thing, right? So you get a lot of wrong results when you even if your search query is right. Okay, so we were getting videos from all different languages, so we had to build around certain of these things to actually figure out how diverse my data is. Okay, so like for gender identification, we have a rule-based algorithm. So you don't need a deep learning algorithm for gender identification thing, but you obviously can train a model for gender identification by manually labeling 100 male and 100 female, or maybe 1,000 male or 1,000 female utterances. But we have a rule-based approach that tells us whether this person, whether the utterance is from a male or from a female, right?
Okay. So, like, when you're talking about a rule-based system, so are we talking about like uh, 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 analyzing the audio samples and figuring out, like, for example, the
Hmm.
average male voice would be within this specific pitch or something, like
Yes.
making those specific thresholds, and based on that, whether few of the thresholds are passed, then we maybe recognize it's a male or a
Yes,
female.
yes, absolutely. I mean, pitch is one of the most important features. So there are two more important features. One is, related to pitch, but I don't remember right now. But yes, pitch is the most important feature. So that is why we have a rule-based approach that if a female is speaking, that then her pitch levels are this. If a male is speaking, then his pitch levels are this. Okay, so that is why we don't need a DL algorithm or an ML algorithm to figure that out for us. That is why we use the rule-based approach there.
So, when we're talking about specific, uh, like, if we give the general example, when we did not have smartphones, right?
Mm,
Then the age came that now everybody has smartphones, right?
mm,
And then the age came that everybody has internet, right? So
right.
now somebody, like, for example, my mom can start a YouTube channel and
Mm,
build an audience, and there's like a lot of adoption of the technology, right?
mm,
Because of internet, right? In the
mm,
same way, like, how do you think, like, when we are building speech recognition systems for
mm,
Indian languages, how can it
mm,
enable us to, like, maybe build better products? And also, like, for example, if we are using Google's like speech recognition thing,
mm,
it might also have like Indian languages in that, right?
mm,
So,
mhm,
what is the difference when we are like tailoring a specific model specific to an Indian language, uh,
mm,
then like maybe using an API to
mm.
do that? So, like, what's the benefit that it brings in? And like,
Okay.
yeah.
Yeah. So first of all, Vakyansh is an open source project, which means that the entire models or the entire research is open source. So that is why I'm able to share all my learnings with you in this podcast. Okay. So the idea behind open source, what is the idea? I mean, why are we doing this? Okay. So because see, if you need to kickstart or maybe build local apps, or maybe there is some student in college, he wants to start building an app that works on local languages or uses local languages, then the problem with the APIs is that it's a very closed ecosystem. Okay, so you have to pay for the API. Okay, so Google is not free. I mean, Google speech to text is not free, and Azure speech to text is not free. You have to pay something for those services. And as a student, as a developer, or as a researcher, I first want to check the potential of what I can do. Okay,
Yeah.
what I can do with the tech. Okay,
Yeah.
so if you want to get a head start, how do you get a head start into voice apps? Okay, and believe me or not, voice is one technology that is the best commercialized thing at the moment. I think every 1 out of 5 households, I mean modern households, have a Amazon Echo or a Google Home at their home, right? And they are basically interacting with a lot of people are interacting with Amazon Echo on daily basis. I mean, the volume of data is huge. I mean, Amazon has a huge data. Google has huge data, but what is there in open literature that we can use as a researcher or as a developer, or maybe build upon that data? So it's basically our language, it's basically our Indic language, but all the data resides with either Google or Amazon or
Yeah.
Azure, right? And all the APIs reside with them. So we are basically dependent upon them. Okay, so this is actually one of our uh, initiatives to reduce that dependency to some bit. Okay, so like we created a Hindi model, right? So we are saying that we have transcribed using the Google speech to text. We have transcribed using the Azure service, but we have made sure that our data has been transcribed from multiple different sources. So once you have data transcribed from multiple sources, deep learning is so powerful that it understands what is the problem with different data coming from different sources, right? And so that is why we are saying that now we have a state of the art model in Hindi that beats some of the benchmarks set by Google or Azure on some data sets, right?
Yeah.
So, I mean, in speech recognition, the benchmark or the metric that is being used is WER, which is the word error rate, which tells like uh, how much insertions, substitutions, and deletions basically your model did in the prediction as compared to the ground truth. But if you understand this correctly, our intention is to create an open ecosystem so that we can say that any person who can collect data can basically build a speech recognition system. Now, if you go to Google and check, there are more than 10,000 languages in India, okay, and we are only targeting 23. And we want to create interest among different audiences, okay? We want to create interest among different people or different researchers, right? So basically, we are saying that anyone can come and train their own speech recognition system, which helps also in preserving the language, okay? And there are two different things. One is the language and one is the dialect, okay?
Yeah.
So there are more dialects than the languages, okay? So I mean, I can give you numerous number of examples. Like a Bhojpuri is something like a dialect. It is not a language, as far as I know. So there are a lot of dialects. So if some people just want to train a model on a particular dialect, now that is also possible with limited amount of data. Okay. So I earlier talked about the need for having 10,000 hours of label data with the new tech coming in, with the new algorithm coming in, which includes self-supervised learning and not supervised learning. So self-supervised learning is equal to unsupervised plus supervised learning, okay? So in the unsupervised step, you can have a lot of audio data alone. And in the supervised step, you can have a limited amount of label data. So now we are saying that even if you have 10 hours of label data in Hindi, then also you can create a speech recognition system in Hindi, a production grade speech recognition system in Hindi, right? And so that is why, I mean, for low resource language like Bodo, Santali, so these are low resource language for which you do not find even speakers very easily, right? So for that, we are saying that, okay, we'll get only 5 to 10 hours of data in the first go. And once we have those 5 to 10 hours of data, we will create our system and we will improve our system once we get data, more and more data coming in from the people.
Okay. So in that case, then definitely maybe you'll have to create pipelines. Like, for example, initially you have some data, and then based on that you're training the model, and then maybe then new data comes in, then that change in data, that variation has to be handled. So maybe
Yes,
then you might be using ML ops and all, like data pipelining in that.
yes. So we are definitely using ML ops, but the problem here is that the speech recognition models are not trained very frequently. Okay, so when I'm talking about retraining, I'm talking about retraining after 9 months or 1 year. I'm talking about retraining after my data gets 10x. Okay, so now if I have 10 hours of data, I'll only do retraining when it reaches 100 hours of data, right?
Yeah.
And definitely we are using ML ops, and we have also open sourced our data pipelines. We have also open sourced our experimentation tracking platform, where you can basically come and train your own models by changing just a few parameters as well. So yes, we are doing all that, and everything that I'm talking about is open source at the moment. Maybe we can have the links to that in the podcast description as well.
Yeah, so in this very important thing that came to my mind was, like, for example, if we consider the general example of, like, for example, not just data science, but like, for example, if I do something, like if I build something, right, and we pass it on to the other generation, so they can use that as a base and build upon that. This
Absolutely.
has been a general pattern. If we say anything, if for example, if we take a very layman example, my dad bought a property, I build a house on that. Maybe
Mhm.
my child would then rent it out. So they are using the existing thing and they build upon that. Like
Right.
we have the example, like in the case of ImageNet, right?
Mm.
They they made a great model. Now
Mm.
a lot of development is being done using that. That
Mm.
level is that. In the
Mm.
same, like I really find this thing, the Vakyansh project, very empowering, because even
Mm.
if it takes some time, right?
Mm.
But then somebody who's a developer in India, somebody who
Mm.
wants to or make solutions in Indian, like uh, area, or
Yes.
maybe in the Indian infrastructure. So in
Mm.
that case, he'll be very like empowered in that sense. And
Absolutely.
like for example, I was researching and then I found out this like project by, I guess, Janani.ai, right?
Mhm.
So these guys, they've built a farmer support system, right? So
Mm.
wherein a farmer can maybe call in Hindi and
Mm.
he can ask like what is the price, right, of the
Mhm.
crop, or it can also suggest like which specific like yojana you can adopt for. So in
Mm.
that case, like, and also like initially you mentioned that you didn't go abroad, but then
Mm.
stayed in India,
Mm.
right? So that is also what I think is very empowering, because what we see is either we become a service for the Western world, we
Mm.
improve the products,
Yeah.
or maybe we create our own products and
Mm.
empower our like
Yes.
country.
Future. Yes.
Yeah.
Yes. Absolutely. I mean, see, uh, the idea of local languages is huge. I mean, if you see, Amazon initially was only in English, right? But quickly they realized that once they start providing their app in Hindi, once they start providing their app in Tamil, then they're able to get a more user base. Okay, they are able to reach more users, right? So Amazon is on a spree to convert app in all the maybe languages, Indic languages, as soon as possible, right?
Yeah.
So similarly, I mean, if you check other apps, Flipkart, right? So they currently have a voice search which is only based in English, but I think they are soon launching something in Hindi, right? So I think the idea is huge. I mean, the platforms, the reach. I mean, I can give you an example. So 70 million people speak Tamil. Okay, 70 million, and 70
Yeah.
million is not a small number. Okay, and if you can target people uh, on your platform using your local language, then why not do it? I mean, why not an app would do it, right? And now suppose Tata Motors. So Tata Motors is coming with an EV, with the new EV, we all know, electric vehicle, right? So they have voice assisted systems inside the car, right? And they are thinking about doing something in the Indic languages as well, right? So I think this has just started. I mean, the support for, I mean, vocal for local has just started, and I think it has a long way to go. And it's not that magically people will stop speaking Tamil, right? It's not that. People are going to get increase only, right? So even if I'm from Punjab, I know three languages. I know Hindi, Punjabi, and English, right? So maybe I'm using Amazon today in English, but tomorrow I may prefer to use it in Punjabi or Hindi, right? For any cases, right? So I think the user penetration, I mean, is huge. I mean, the apps that can go local, as you also gave an example of farmer, right? So a farmer is calling in and speaking in his native language. Now, if you want to automate the call centers, suppose you want to automate the call centers for some queries, right? So first
Yeah.
of all, the automated system needs to understand what the farmer is saying in native language, right? So the native language has to be transcribed first into text, and then a lot of algorithms have to run on that particular text to find out what the query is, right? So the different amount of voice bots, chat bots are also coming in local languages. And I think as I said, this is just the starting. I think we would see a lot of tremendous growth coming in by 2025 in this space.
Yeah, definitely. I've seen like there's been a lot of shift in the entire world in order to capture the Indian market, because just of the sheer numbers that we have. We have
Yes,
even seen
absolutely.
like how YouTube has changed its strategy completely
Mm,
because so that it can focus on the Indian people. Maybe the people who get like reward from YouTube might
mm,
be less in the amount of money that is paid, but then the number that we have,
mm.
like
Right.
market that can be penetrated is very huge. So
Yes.
definitely, if we have great like speech recognition systems, then definitely we can sell it to them, or maybe there's
Mm.
like a lot of business opportunity in that sense. Yeah.
Yes, absolutely. So even we are saying that if you want to create a SaaS, if you want to create a SaaS using Vakyansh models, you can very well go ahead and do that. Okay. If you want to offer our models as a service to some organization to do some speech recognition tasks, you can very well do that. We don't mind doing that. The only thing is that we just want to kick these things starting out. We want to kick the interest of people coming in this.
Yeah. Okay, so now, like as we have talked a lot regarding the speech recognition and all, so like for like somebody who's like just starting this journey of data science, or like this journey into speech recognition NLP, so what do you suggest should be the starting point? Because like there's a lot of development and a lot of things to learn. So how can one like declutter oneself and just focus on the learning path?
Yes, so see, this is the hot and burning question that I've been asked a lot of times. And even if I would have started in 2021 learning about data science, I would have got lost somewhere because uh, the amount of resources is huge. I mean, yeah, there are huge number of resources. Everybody claims that they have the best course. Everybody claims that their course is the best and they are the best and they should do it and all. I mean, you cannot do each and everything, to be honest, right? You need to focus on a particular thing. And what I have seen is, I mean, this is my personal view. What I have seen is that Indian edtechs are not helping much in terms of the quality of data science education. Okay, and I don't want to name any certain platforms, but I don't like their offerings at all. And I have been vocal on LinkedIn about all of these things, and I want to guide as many people as much possible that don't fall into the sales trap. Okay, so if a sales guy calls you and says that you do this course and you will get 10 lakh package, 20 lakh package from whatever you're doing, that is never going to happen. That is my first advice. I mean, ignore all the sales guy that are there in that are calling you daily to take this data science course and all. And from my experience, I have reviewed. Okay, so let me tell you a little bit about my background. So I review courses. So I have reviewed courses from Udacity, Coursera, Manning, and some Indian edtechs. Okay, and I do a lot of reviews, and I've seen that the quality. I mean, the data science courses are quite introductory. I mean, there is a lot of introductory courses that are present in data science currently, and beyond introduction we need to go into depth. Okay, we need to go into depths of computer vision, we need to go into depths of NLP, and you cannot have just one course in which you train a cat versus dog classifier using an CNN, and then maybe create a sequence model using LSTM, and then you can say that you're an expert at both NLP or computer vision, right? So these are very broad fields. Okay, of course, I mean, you need a starting point somewhere, and that starting point has to come through a course. But my advice would be to go for courses that are there on YouTube, the Stanford courses that are present on YouTube already for free. And if you find that tough, okay, if you find that tough, then trust platforms like Udacity and Coursera. Okay, I personally trust Udacity a lot. So basically, my way of learning is the top-down learning. Okay, so top-down learning is basically you do a project first, and then you understand what is happening behind the scenes in that particular project, right? So basically, Udacity is a project-based website where you can go and execute a lot of projects without going into theory in detail. Once you have understood how to do things practically using the coding and all, then you can go to Coursera or deeplearning.ai to understand why you did this. Okay, so if you are using Adam, so Udacity people will tell you, okay, use Adam as an optimizer in deep learning algorithms, but they will
Yeah.
never tell you why. Okay,
Yeah.
so you would start using Adam everywhere, but if you want to know why you are using Adam, then AndroNG is your best friend. You need to go to deeplearning.ai and understand, okay, Adam is a combination of a momentum plus SGD, right?
Yeah.
So then you get to understand the maths behind Adam, like how it eventually decreases the time to optimization, right? So all those mathematical concepts, I think AndroNG is one of the best teachers. So just two approaches: either go for Stanford YouTube courses, or go for uh, the courses on Udacity plus Coursera. And if you're not able to afford those courses, there is always scholarships for those courses which you can apply. And those people are very generous. So they keep on running certain programs where you can apply for scholarships, or you can become a project reviewer. And once you get the opportunity for project reviewer, you get the access to the course by which you can audit the entire course. So my way of doing these things is like this only.
Okay, okay. So like when you were talking about analyzing a specific course, right? So definitely this is a very important thing that we have faced, and I've seen a lot of people are also facing that the course that they would take would
Hmm.
eventually lead to like is like there's a lot of difference in the actual world, how the
Hmm.
thing is being done and how the course is being done, right? So
Hmm.
definitely when it makes you more market ready is very important, because eventually if you know maybe that in this specific case Adam would be a better optimizer that I would
Hmm.
use. So
Hmm.
definitely you know, yeah, maybe I don't know how it works, but
Hmm.
this would be something that I can prefer rather
Hmm.
than others, right?
Hmm.
And then obviously in the specific in that scenario you are able to deliver, but then
Hmm.
obviously when you want to improve, and
Hmm.
obviously there's like a lot of uh, very specific things that you would want to achieve. In that case, maybe the specific understanding of which optimizer would be better in which scenario takes uh,
Yes.
priority, right?
Yes.
But and another thing that I've seen is like most of the courses I would also not name, but
Hmm.
they like if we like the context of this entire conversation has been
Hmm.
data science for empowerment, right?
Hmm.
So like what had been the case of India has always been like people have been like kept away from education, right?
Hmm.
Like we used to see in the earlier ages, right? The
Hmm.
Brahmins used to get all the education, other people would be
Hmm.
kept away from the education. But then if we can empower people, if we can
Hmm.
make affordable AI, right? So
Hmm.
definitely that is what can bring empowerment, because most of the courses are like either crossing 1 lakh, right? And
Hmm.
even after that people are not at that point to be to deliver, right?
Hmm.
And most of the these things also have this reoccurring payment
Right.
scenario where
Subscription model. Yes.
yeah, so that is not empowering.
Hmm.
Obviously, maybe courses are good. Like
Hmm.
as you also mentioned in your LinkedIn post, right? You would prefer a course because it will give you synthesized information. You don't want
Hmm.
to waste your
Right.
time.
Right.
But then,
Absolutely.
which course to choose is also a very important thing. Yeah.
Hmm. Yes. So I mean, saving time is very important, but you shouldn't go bankrupt to save time. Okay, you shouldn't have a loan basically to save your time. Okay, so that is not going to help you in the long run. If you ask me, I mean, from my financial point of view, I would never take a course that costs more than my pocket, right? So
Yeah.
I think there are a lot of individual content creators as well that are building good courses, and their pricing point is also good, somewhere
Yeah.
around 4,000 to 5,000. And I think that is affordable by the people, right? The only notion is that, I don't know, for some reason, people tend to go for highly priced courses. And if you ask me, I think education is free, but degrees are costly. Okay,
Yeah.
so all the online degrees that you see are costly, and I don't want to actually go into the names of the edtechs that are doing this, but I think they're not doing anything different from what it was there previously, right? It's just basically a business game, right? What Udacity or what Coursera is doing is a little bit different than what edtechs they are doing, right? So that is why I tend to prefer those platforms, because see, if you go to Udacity, you
Yeah.
check their instructors, okay? You check who is teaching the course, and you will understand that people who are building recommendation models in NVIDIA are coming to teach in Udacity. People who are building self-driving cars at Google are coming to teach at Udacity. Okay, so people from the field are coming to teach at Udacity. So that is what I like the most about their courses, right? So it is not taught by someone who has been given a contract to deliver a course, right? It is being taught by someone who is doing this thing currently in their field,
Full
and they
experience.
want, yeah.
Yeah.
So that is why I like their courses a lot.
Definitely, like as you mentioned, obviously, we know like there are few YouTubers and other people who are providing the course in very affordable prices, right? And we also definitely feel that how empowering that is,
Hmm.
definitely. And
Yes.
obviously you cannot just keep on like investing money with no return, obviously.
Yeah.
The Because what I see is like because of internet, because of all these resources, we are becoming more aware, but maybe when you initially started, at that
Hmm.
point there might not have been that much
Yes.
resources. So
Absolutely. Yes.
the entry barrier for somebody who is coming now
Hmm.
is very less in comparison to that, because a lot
Yes.
has been done. Yeah.
Yes. Absolutely.
Yeah. So, like, what are your specific like learning resources or any books that you would specifically recommend? Like, how's your learning pattern? Because there's like a
Uh.
lot of things that are
Hmm.
going on in the
Hmm.
AI domain, and you
Hmm.
cannot always catch up. So, what's like your
Yes.
take on?
Yes. So see, the beauty about this field is that uh, you have to constantly go on learning. Okay, so it's not like that if you have learned something, then you say, okay, I have become a master of deep learning. Okay, because you'll find that once you say that, 7 days later there will be a new paper, state of the art paper that is coming on, right? I can give you an example of computer vision at the moment. So there is uh, every week there is a new state of the art paper coming in object I mean classification based on ImageNet results. Okay, so it's very hard to keep up with the research also that is going on these days, right? So what do you do then? I mean, I tend to follow books. Okay, so I mean, there are two books that I've read completely. I keep on skimming through a lot of books online, but two books that I have read completely are one is Deep Learning with Keras, which is written by Vakyansh, who is the creator of Keras. Okay, and his second version of the book is coming in December. I would 100% recommend that book any day, anytime to anyone who is interested in deep learning. And the second book is Hands-on ML using Scikit-learn and TensorFlow by Aurélien Guérin, right? So that is also a very decent book to get started with classical machine learning, or to get started with TensorFlow and Keras. I think the second version of the book is out after TensorFlow 2.0 as well. And
Yeah.
both of these books I have read not just one time, but 5 to 6 times. And I think it is better to read one book multiple times than to read five books one time, right? So that is my philosophy. I do skim around a lot of new orally books that are coming in the market, because I think, as I said, I mean, those books are also written by practitioners in the field. And I want to learn from the experiences of people who are writing those books as well. So that is why I also wrote a book with Pact, which was basically a Bitcoin price predictor in
Okay.
2019. So that is published on Amazon. And So that is my learning pattern. I mean, ideally I don't start with a video course. I start with the book if I can find on a particular topic. And I think there are a lot of open source books, if you ask me. I mean, for statistics, there is a book, open book, like I forgot the name of the statistics book. Uh, but I think I'll let you know. I mean, it's Open Statistics or something. I mean, it's a very easy book to follow, and I mean, all the concepts are covered in the book. So you do not even need to go for a paid resource, right? So internet is your best. As I said, I mean, education is free. I mean, degrees are costly, right? So if you want to be a certified or get a degree, then you have to pay a huge amount of sums. You need to have an EMI or something. But if you want to get educated, then I think internet is your best friend.
Yeah, definitely. When we're talking about the books, right? So what I feel in case of books, the thing that is very empowering is when you're studying a specific book, right? You will get a end-to-end entire data regarding a specific concept that you're studying, right? You can they'll maybe start from the basic intuition, then they'll give you comparisons, and then like if we talk about the O'Reilly book that you're talking about, hands-on machine learning with scikit-learn, right? So in that, when they are talking about a specific type of problem, so they'll start with the problem statement. They'll give you all the different variations with snippets of code. So maybe that helps you to have a wholesome approach in understanding what all different options we have. There is
Absolutely.
obviously, like for example, if I'm solving a specific problem, there would be a approach that is majorly followed, right? But like for example, if we are going through a YouTube video, so the YouTube video is constrained to a specific topic, right? uh, it'll maybe start from some initial point. uh, it'll have some basic assumption that you specifically know about something. They'll talk about a specific topic and then they'll leave it somewhere, right? So
Yes.
you know about the deep concepts, right? But you don't know what's the basic building block.
Yes.
So, and apart from that, another thing that I feel is like there's a lot of noise when we are using our smartphones or laptops to, because either we'll get distracted with the recommended videos or ads or something. But when you are reading through a book, there'll be no notification that the book is going to
Absolutely.
be.
Yes.
Yeah.
So a lot of people get lost in the distractions, right? So that is why I have decided that if I'm ever going to launch my own data science course or something, that would be on a platform that would be created by me. Okay, it wouldn't be on YouTube or Udemy, because once you see the effect of recommendation engines, then you'll understand that there are a lot of distractions going on, right? So it's a similarly, if you go to shop at Amazon, right? If you want to buy a particular thing, but in recommendations you are shown a lot of other things as well similar to this, you end up buying those things as well, right? So that is why I'm not a big fan of these personalizations or customizations. So that is why I think the noise should be reduced. Another resource that I would like to mention briefly is Free Code Camp. Okay, so if you would know, Free Code Camp is they also have their own website, and they also have a YouTube channel which is free of ads. Okay, so basically they publish full length courses in micro courses like Docker. If you want to learn what is Docker, what is Kubernetes, you can head to Free Code Camp and you'll find a 6-hour video, 7-hour video taught by a practitioner. And basically you can as a I mean you'll get the access to the entire code base as well, and you get the access to the problem statements and everything else as well. So that is again a very good resource if you ask me. So paying for any before paying for any course, I would suggest go to Free Code Camp, search if they are providing that course for free. If they are providing, just take that course. That would be sufficient enough.
Definitely. For all the links and all the referenced books and courses, we'll definitely try to add the links in the description once we
Sure.
publish this podcast.
Yeah.
So, as we are like at the end of this podcast, I have only two questions to ask you. First one is in your entire career as a data scientist, right? You have faced a lot of different problems, in different domains or different types of problems, right? So in all the problems, what has been the core common things that you have realized? Like these are the core competencies in terms of maybe the mindset, or how do I approach any problem that you have figured out, that you implement. Just to give you a little context, like for example, for us, the initial coding language that we try to learn is difficult, because in that case, like for example, we generally start with C or C++, right? Wherein we learn what is a class, what is a keyword, right? How is memory managed, right? So in same context, in data science, what have you felt are the common factors that you need to develop in yourself?
Yes. So I think the basic understanding of machine learning is very much important. Okay. So when I say the basic understanding of machine learning, I'm talking about basic concepts of classical machine learning, like what is bias, what is variance, how do you solve overfitting, how do you solve underfitting, right? So if you're able to grasp all these concepts conceptually, what is a sigmoid function? Where do you use a sigmoid versus a softmax, right? So all of these things play a major role in developing your intuitions on the advanced things like deep learning or maybe NLP or computer vision, right? So yes, basic coding experience is also, I think, a bliss. If you are a good programmer, if you have a prior coding experience, then I think learning Python is nothing for you. I mean, as you said, I mean, I also started learning with C#. Then I jumped to JavaScript. And what I remember, I'll tell you from my experience, I had only 12 hours to learn Python, because after 12 hours, I had an exam. Okay. So in that exam, the outcome was that I had to I have to solve a data structure and algo problem with Python, using Python. Because that was the requirement of getting selected in that self-driving car thing that I talked about in Infosys, right? So within 12 hours, I was able to learn Python. Okay, so basically, if you are good at a certain programming language like C# or JavaScript, then it won't take longer to you to grasp the concepts of Python, because to me, I think the Python is broken English, right? So data structures are very easy, arrays, list, I mean, those are very easy to iterate and all, right? But if you want to master your skills, then you can go ahead with the competitive programming course or something. Personally, I am not good at that much at competitive programming because I've never taken a lead code or course or something like that. But if you want to be a good programmer in today's age, because a lot of companies are testing freshers on data structure and algorithms, then you need to up your game a little bit. For that, I think lead code practice questions would be good. Of course, I'm not a good person to talk about that because I personally haven't done anything on lead code. But that is one thing. The second thing is a lot of people say that how do I get practical experience before applying to a job? Because a lot of jobs currently are asking for a practical experience. And the idea here is that there is a platform called Kaggle, right? Yeah. We all know. So Kaggle is a platform on which there are multiple competitions, multiple hackathons, multiple competitions, multiple data sets. So people all around the world would come to Kaggle to do that work. I mean, to share their knowledge, right? And I've seen like the top people on Kaggle. My mentor, my imaginary mentor is from a Kaggle. Okay, so my imaginary mentor is Chris Diot. So he's working as a senior scientist in NVIDIA. He doesn't know me, but he's my mentor. Okay, because I have learned a lot seeing his notebooks and seeing his discussion forums. Okay, so the good part about the pieces on Kaggle is whenever you're creating such pieces, you never know that who is going to read that piece. Okay, and how many people you are inspiring by writing that piece, right? So that is why Chris doesn't knows me, but he's my imaginary mentor, and I give a lot of credit to my success to Chris because I have learned a lot of practical concepts from him, basically his kernels and all of those things. So once you start reading other people's approach, then you start building intuitions like how one problem can be solved in multiple different ways. Okay,
Yeah.
and then maybe you can apply that thinking to your next competition or next data set thing. Again, I mean, I'm not very active on Kaggle because I have a lot of field work to do as well. But for people who do not have a job in data science currently, I mean, practical experience in data science currently, I think Kaggle is the best platform for you guys. And the sooner you enter this platform, the better it will be for you.
Yeah, definitely. Like looking into other people's notebooks and their approaches really helps you get a better approach as to like what are the different avenues the problem could be approached in.
Hmm.
So, as we are coming to the last question of this
Hmm.
specific
Hmm.
podcast, and
Hmm.
obviously anybody can like learn from watching this podcast, but for the specifically the people who are watching it in India, right?
Hmm.
And I would like to talk about this in Hindi only, right?
Hmm.
जो भी बंदा अभी इस टाइम पे इंडिया में डेटा साइंस के डोमेन में एंटर करना चाहता है एंड मे
Hmm.
बी बिकॉज ऑफ द फाइनेंशियल बैरियर और मे
Hmm.
बी ड्यू टू लैक ऑफ नॉलेज, राइट, वो डर रहा है और मे बी वो फील कर रहा है कि यार मैं इस फील्ड में कैसे जा पाऊंगा. सो लाइक आपका आप क्या रिकमेंड करोगे कि व्हाई वुड समबडी वांट टू परस्यू समथिंग लाइक डेटा साइंस? क्या उनको अपने अंदर फील करना चाहिए कि हाँ ये मेरे लिए मोटिवेटिंग फैक्टर है कि हाँ मैं स्टैट्स भी लर्न करूँ, मैं प्रोग्रामिंग के बारे में भी पता करूँ एंड देन मॉडल्स के बारे में भी पता करूँ और अलग अलग जगह से इंफॉर्मेशन इकट्ठी करूँ, मतलब इतनी मेहनत मैं इस डोमेन में डालूँ, तो क्या मोटिवेटिंग फैक्टर है तो उसको
राइट, सो आई थिंक जो सबसे बड़ा मोटिवेटिंग फैक्टर है इस कि यू आर इन्वॉल्व इन साइंस. आप एक साइंस में इन्वॉल्व हो, राइट? सो साइंस का मतलब है कि अगर आप 100 एक्सपेरिमेंट करोगे तो 99 हो सकता है फेल हो जाए बट एक पास हो, राइट? सो आपको एक्सपेरिमेंट करके देखना पड़ेगा. देन इट्स योर क्रिएटिव थिंकिंग कि आप क्या एक्सपेरिमेंट और कर सकते हो, राइट? कि आपने एक तरीके से एक एल्गोरिथम डिजाइन किया, राइट? अब आप उस एल्गोरिथम में क्या चेंज करोगे कि आउटकम डिफरेंट हो, राइट? सो जैसे अगर आप कोई वेबसाइट बना रहे हो या कुछ बना रहे हो तो उसमें क्या होता है कि आपको इनिशियल सेट ऑफ रिक्वायरमेंट जो दी जाती है वो क्लियर होती है कि आपको ये वेबसाइट हमें बना के देनी है, ये सब करना है. बट डेटा साइंस में ऐसा कुछ क्लियर नहीं है, राइट? एक प्रॉब्लम है, उस पर आपको रिसर्च करना है. तो बेसिकली आपकी रिसर्च कुछ भी हो सकती है. आप कुछ भी कह सकते हो मैं अपना डेटा चेंज कर दूंगा, ठीक है? तो सबसे पहले बात तो है कि यार मैं अपना डेटा चेंज कर दूंगा या मैं अपनी डेटा की प्री प्रोसेसिंग की टेक्निक चेंज कर दूंगा, राइट? तो आपको बेसिकली एक्सपेरिमेंट करना है. जैसे केमिस्ट्री लैब में हम जाते थे, 2-4 केमिकल मिक्स करके देखते थे, राइट? वो प्रैक्टिकल लैब क्यों होती थी? हम केमिस्ट्री पढ़ भी तो सकते थे, राइट? कोई भी हमें बता सकता था नोटबुक से यार कि आप ये इस केमिकल को उस केमिकल के साथ मिक्स करोगे तो ये होगा, राइट? बट जब आप लैब में जाके देखते हो कि एक केमिकल दूसरे केमिकल के साथ मिक्स हुआ, अच्छा ये आपकी फाइंडिंग्स हैं कि ऐसे फॉर्म बना उस केमिकल में, ऐसा बाहर आया, तो वो फाइंडिंग्स आप मतलब आगे यूज कर सकते हो, डिफरेंट प्रॉब्लम स्टेटमेंट में यूज कर सकते हो या उस चीज को डिफरेंटली कर सकते हो, राइट? और अभी भी कुछ ऐसी प्रॉब्लम्स हैं जो कि आप डेटा साइंस से ऑटोमेट कर सकते हो, राइट? आपका मतलब आपकी कुछ ऐसी प्रॉब्लम है जिनमें आप ह्यूमन इंटेलिजेंस को स्केल कर सकते हो यूजिंग आर्टिफिशियल इंटेलिजेंस, ठीक है? तो अगर आपको वो करना है बेसिकली, तो मैं हमेशा कहता हूँ कि लोग डेटा साइंस, आई मीन जो क्लाइंट है बेसिकली, दे आर नॉट डूइंग डेटा साइंस फॉर द सेक ऑफ डूइंग डेटा साइंस, ओके? एट द एंड ऑफ डे वो क्या चाहते हैं कि उन्हें भी कुछ फायदा हो, दे उनको भी कुछ मोटिव हो, राइट? दे आल्सो आर एबल टू सेव सम डॉलर्स, राइट? तो जैसे हम रिकमेंडेशन इंजन की बात की हमने, तो अगर मान लो अमेजन का एक रिकमेंडेशन इंजन है, अगर आप उस इंजन को 1% इंप्रूव कर देते हो, मान लो 10% इंप्रूव कर देते हो, मान लो 1% जितना भी इंप्रूव कर देते हो, और उनकी सेल अगर मान लो $1 बिलियन बढ़ जाती है सपोज आपके चेंजेस के साथ, सो दैट इज अ गुड थिंग फॉर द कंपनी, राइट? एंड यू विल आल्सो बी रिवॉर्डेड इन सच अ वे, ओके? सो दैट, आई मीन, आप इम्पैक्ट देखिए कि कितना इम्पैक्ट कर सकते हो आप लोगों को. जैसे वी आर क्रिएटिंग, हम वाक्यांश के लिए हिंदी में मॉडल बना रहे हैं, तमिल में बना रहे हैं, हम क्या कह रहे हैं कि हम 70 मिलियन लोगों को इम्पैक्ट कर सकते हैं एक तरीके से, कि हम कह सकते हैं कि यार हमने एक ऐसा मॉडल बनाया है जो शायद किसी की भी आवाज पे चले, ऑब्वियसली वो सबकी आवाज पे नहीं चलेगा, बट हम कह सकते हैं कि शायद ये चले, और अगर जितने ज्यादा लोग टेस्ट करेंगे उतना हमें हमारे मॉडल के बारे में पता लगेगा, उतना हम इम्प्रूव करेंगे। तो अगर आपका वो माइंडसेट है कि मुझे एक्सपेरिमेंटेशन करना है, मुझे डेटा कलेक्ट करना हो, ऐसी प्रॉब्लम सॉल्व करनी है जो डिफिकल्ट है, ठीक है, ऐसा नहीं है कि जो यूआई बना रहे हैं या वो बना रहे हैं वो डिफिकल्ट नहीं है, वो भी डिफिकल्ट है, बट कुछ ऐसी प्रॉब्लम जो आपको ऑटोमेट करनी है यूजिंग एआई, तब आपको फिर इस फील्ड में आना चाहिए। इस फील्ड में आने का आपका मोटिव सिर्फ यही नहीं होना चाहिए कि यार मुझे ज्यादा पैसा कमाना, राइट। तो मैं, अगर आपका यही मोटिव है तो मैं आपको बता दूं कि कुछ यूआई डेवलपर ऐसे भी हैं जिनकी डेटा साइंटिस्ट से भी ज्यादा सैलरी है, राइट। सो हाँ, सो वो मोटिव नहीं होना चाहिए, पैसा मोटिव नहीं होना चाहिए, मोटिव होना चाहिए आपका माइंडसेट की यार मुझे ये काम करना है। जैसे मुझे क्या होता है कि इफ आई डोंट वर्क, आई मीन लाइक पीपल से दे वेट फॉर वीकेंड्स, आई डोंट वेट फॉर वीकेंड्स, ओके। मेरे लिए हर दिन सेम है, और मुझे, आई मीन नोबडी टेल्स मी टू डू एनीथिंग, आई बेसिकली, बिकॉज आई एम एंगेज्ड इन दैट वर्क, आई लाइक माई वर्क, ओके, वॉट एवर आई डू आई लाइक माई वर्क, so that is why nobody has to tell me कि आपको ये करना, right? So if you want to have something like that, then yes, data science is a good option there.
Yeah, definitely. एक तो आपके अंदर वो मोटिवेशन भी रहना चाहिए कि यू वांट टू इम्पैक्ट, एंड सीइंग द फैक्ट कि डेटा साइंस कितना ज़्यादा इम्पैक्ट लेके आ सकती है। लाइक जैसे हमने कन्वर्सेशन में भी बात की कि इनिशियली जब इंटरनेट आया था, जब फ़ोन आया था, सो वी डिडंट नो कि इसका कितना इम्पैक्ट हो सकता है, बट नाउ इट इज़ लाइक वाटर और इलेक्ट्रिसिटी दैट वी आर यूजिंग इंटरनेट। सेम वी हैव अ लॉट ऑफ डेटा, बिकॉज अब हम वो इनिशियल थ्रेशोल्ड पार कर चुके हैं, बट नाउ हाउ वी आर गोइंग टू यूज दैट डेटा एंड हाउ वी विल एबल टू इम्पैक्ट, डेफिनेटली हमको भी नहीं पता, बिकॉज देयर आर ऑफ थिंग्स दैट टाइम विल टेल, बट डेफिनेटली the impact that you want to make should be the key thing. So Harveen, it has been like a great honor and a great privilege to like have you on this podcast, and I like really enjoyed all the different conversations that we had, ranging from like what approaches we follow in speech recognition to then like how the data science domain can empower the entire country and like bring change. So like thanks a lot for giving your time.
Sure. Thank you for organizing this. I usually don't go to podcast or something, because I said I will only go to podcasts when I'll start my own YouTube channel, but I think I have been procrastinating for around 3 years on that YouTube channel. So that is why I decided, okay, let's go for this one and let's see where we go with this.
Yeah, sure. I hope that you also enjoyed.
Yeah, sure. I enjoyed a lot. Yeah.